Welcome back to the Stellantis Tech and AI podcast. I'm Dale Jewett, a generally curious person and your host. And in this episode, our guest is Greg Fadler, who is the Stellantis manager of the Aerodynamics Engineering and Wind Tunnel Operations departments. So Greg, thank you very much for taking some time to blow into our podcast.
Thank you.
How many more trite wind jokes can I make, huh? Because I would say we could call this one blown away. That one's pretty trite. I think we should call it like cool breeze or something like that because I've been to the wind tunnel before.
I've been tagged with all of them in the past.
This is a great topic of aerodynamics because I believe it plays a huge role and people don't necessarily understand how it works, probably because you can't really see a whole lot of it. But first, why don't we start a little bit with Greg? Tell me, how did you get where you are today?
Well, I have 3 degrees. I have a bachelor's degree in aerospace engineering, a master's degree in aerospace engineering, and an MBA. And so I started as a young aerospace engineering student and went into the aircraft business at first, and then moved back home to Michigan, where I live happily with my family and where my wife and I grew up. And so it became a fairly easy thing for us to kind of go back to where our families were and where our roots were. And I've been in the auto industry now for over 30 years.
Awesome. So you're pretty much a rocket scientist.
Yeah, that's correct. Aerospace engineering is the study of aircraft and spacecraft.
Okay. Well, I'm glad you decided to make ground-based transportation your thing because I'm sure we benefit greatly from it. You run the wind tunnel that is part of our complex in Auburn Hills, Michigan. How long have you been associated with that?
I've been the head of the Aerodynamics Engineering and Wind Tunnel Operations essentially for 10 years, and my title has changed a little bit over that period of time, but I've been in that general role for the last 10 years. The wind tunnel has been in operation for 22 years, and when the wind tunnel was originally designed and built, I was fortunate enough to have a tour of it on its opening day.
Well, we've made some recent upgrades to this wind tunnel, which is part of the reason why we're talking about it. Give me the quick rundown on what we've done.
So when the facility was originally designed and built by a couple of my colleagues, it was designed around a fixed ground balance, which is basically the device that measures the forces and moments, the aerodynamics forces and moments that are applied to the vehicle. And about the time that our wind tunnel was designed and built, the technology was shifting quickly into moving ground technology. But our team decided that the best way forward was to stick with the proven technology, the fixed ground technology. And so the facility was built that way and operated all the way through to the end of October of 2023 in that configuration. But all wind tunnels today generally are built, road vehicle wind tunnels that is, are built with a moving ground technology, which means the ground under the vehicle moves and the tires rotate. So if we think about this in the real world as if there's no wind, the air is fixed and the ground is fixed and the vehicle is moving. And so the vehicle's moving relative to the air and the ground. Well, so the issue with the old wind tunnel was that the vehicle was fixed and the ground was fixed and the air was moving. In the new solution, we have the vehicle fixed, the ground is moving and the air is moving. That is a more accurate representation of the real world.
Okay. Interesting stuff. So in our wind tunnel, how big of a vehicle can you fit?
It's the new balance and the facility was originally sized for our biggest crew cab long box pickup trucks. So we can literally test the biggest 3,500 vehicle we sell in North America.
Okay.
It was designed to accommodate that scale of vehicle.
So I think most of our listeners would generally understand the idea, the concept of wind resistance. And you look at a variety of vehicles on the road today. You looked at 3,500 pickup truck that you talk about, pretty boxy kind of shape versus when we were building the Dodge Viper. That's a very low, very slick shape, and I think you could understand the difference of between those two vehicles in terms of wind resistance.
Sure.
What difference, or are things different because now we're transitioning into a mobility period where plug-in hybrids and electric vehicles are becoming a bigger issue? Do
Yeah.
the rules of aerodynamics change?
No, the rules stay the same, but they're really it's interesting from the standpoint because the horsepower required to move through the air, and therefore the fuel required to move through the air, goes up with the cube of speed. So let me explain that in really simple terms. So
Mm,
if if you double your speed, the power and fuel required to move through the air goes up by a factor of 8. So in other words, it's like 2 to the third power, right? So in other words, if you're going 40 miles an hour and you decide, hey, I want to go 80 miles an hour, you're going to use 8 times more fuel or 8 times more horsepower to move through the air at 80 than you're going to use at 40. And that's a really huge difference. Now, I should probably change that, folks, and just say that if you want to go 70 miles an hour, you're using 8 times as much fuel as you would use at 35 miles an hour. And so if you think about highway speeds versus around town speeds, you're using 8 times as much power and fuel to move through the air at 70 than you would be at 35. And that's where aero becomes really important, is as you get to the higher speeds, it's a uh, it's a hugely compounding effect. And the beauty of electrification is we can regenerate. And when we have low aerodynamic drag, it takes less power and fuel to accelerate to 70. But then when you decelerate from 70 to a slower speed, now you have more power available to grab in the regen cycle. And that's why aero becomes so important to the range of hybrid and electric vehicles, is that it not only reduces the power to accelerate, but it gives you more power available to regenerate as you're decelerating.
that's very interesting. It kind of helps explain why you notice your state of charge goes down faster when you're on the freeway than if you're just tooling around
Abs-
town in a vehicle.
Absolutely.
Um,
Absolutely.
and
And it's the
American, I'm
same for
sorry.
aircraft and ships and everything else. Anything that's moving through a fluid, the power required to move through the fluid goes up with the cube of speed.
Okay. So in general, and I'm not a stylist or anything, but most electric vehicles I've seen these days do away with a grill opening at the front of the car. Is that because of aerodynamics?
Yeah, we still need cooling flow for electric vehicles because we need to operate climate control systems and we need to maintain the temperatures of the batteries and things like that. So there are always cooling systems on board, but you can efficiently, but you require less cooling for an electric vehicle than you do for an internal combustion engine vehicle. And so that's the reason why you see fewer grill openings. They're still generally cooling systems, but the cooling systems are there to maintain the battery or to maintain occupant comfort instead of cooling an internal combustion engine.
Okay. And based on our testing and experience beyond just sort of limiting the amount of air going in the front of the vehicle, are there other areas that are primary areas we pay attention to for improving the drag or reducing the aero drag on a vehicle?
Yeah, we look at everything, to be honest, and that's the reason why we're so focused on the moving ground technology. Is the underbody optimization is really critical. There's a lot of drag in the underbody. There tends to be a lot of drag on the upper surface as well, and we've had the ability to focus on the upper surface uh, for a couple of decades with the old wind tunnel, but now that we've made the upgrade to the wind tunnel, we can now focus on the underside. We can focus on the aerodynamic drag of the rotating wheels and tires, which is a little unusual. Most wind tunnels don't measure the drag associated with the tires and wheels rotating through the air. We have the ability to do that in real time and optimize that aerodynamic drag as well.
Okay. I have to ask a very basic question because I've always wondered. I've seen our wind tunnel in action. The smoke stream helps you visualize the path of the air going over the vehicle. But how exactly do we measure wind resistance? Are there sensors on the vehicle?
So yeah, and they're not on the vehicle. They're under the floor, and it's attached to the vehicle through the struts that we use now to attach at the rockers, and through the wheels and tires and the so anything that is touching the wind tunnel, we actually are measuring the forces. Touching the vehicle and the wind tunnel at the same time. We're measuring the forces at those contact points. And when we measure the forces, we measure them in 6 degrees of freedom. So everybody's familiar with drag, but we also measure lift, we measure side force, we measure the rolling moment, the pitching moment, and the yawing moment. So those 6 degrees of freedom define how the vehicle is moving across the surface of the ground or across the wind tunnel balance. So we're measuring all of those, and those other degrees of freedom that I mentioned are really important as speed increases, because then we start to worry about high speed, the high speed handling qualities of the vehicle.
Okay. In addition to the changes we've made with the moving ground plane inside the wind tunnel, my sense is the real magic happens in the control room. Have we made changes there?
Yeah, so the entire data acquisition system was replaced when we upgraded the balance to the moving ground system. And I should define the word wind tunnel balance, because we literally balance the vehicle on the balance in all 6 degrees of freedom. So we install the vehicle and we kind of zero everything out. So when the wind's not blowing, everything's in balance, right? There are no spurious forces. And then when we add the wind, the difference between that kind of zero force state with the wind off and the wind on force state, the difference between those two conditions are the aerodynamic forces and moments.
Is the wind always head on to the vehicle, or do you turn the vehicle sideways to try and, I don't know if you're interested in measuring us, I know what it's like when I'm driving on the freeway on a windy day.
Yeah, you bet. We do. And in fact, we have the ability to test to plus or minus 90 degrees of yaw. And so if you think about that, right, we have the ability to do plus or minus 90, but if we install the vehicle backwards on the balance, we can also do 90 to 180. And our tunnel has been used in the past to develop high-speed motorsports safety devices that are used in spins. And so as a result, we can still simulate that in our wind tunnel. And so that's a pretty critical thing to do. And lots of moving ground wind tunnels are limited to maybe 20 to 30 degrees of yaw, whereas we still have maintained our the ability to go all the way to 90 degrees. So a great benefit for us, but it also gives us the ability to simulate a lot of things beyond just a few degrees of yaw, like you would see on the highway, all the way out to 90 degrees, which would basically mean that the wind is coming right at your side window.
Okay. Interesting. So we must generate a ton of data anytime that we run something through our wind tunnel.
Yes.
What are we doing with all of this data?
So the first thing we do, and the most important one for us, at least in terms of our main function, is to reduce the aerodynamic drag. So we measure the force, and then we non-dimensionalize the force using the frontal area of the vehicle and what we call the dynamic pressure, which is, and if you think about, well, what's pressure times a frontal area, that gives you a force, right? And so drag coefficient is literally how efficiently the vehicle can move through the air. So drag coefficient of 0.3 means that we're using 0.3 or 30% of the total stagnation pressure for that frontal area is the resistance of the vehicle. So if you could imagine, if we perfectly stagnated every molecule of air that came towards the vehicle, that would give us a drag coefficient of 1.
Okay. Is AI a help to us? I mean, we have this data. Are we able to use
Absolutely.
modern technology to help us speed these calculations?
Yeah, so we have a complete suite of artificial intelligence and also computational fluid dynamics, and an outstanding team that assists us in that role. So all of the tools in aerodynamics are useful, right? There's a wind tunnel tool, there's a CFD tool, and there's also an AI tool. And each of those tools help us as we develop our products. We're always seeking the best balance between cost, quality, and throughput. And we integrate the three tools to be able to give us the best balance between cost, quality, and throughput. And so as we think about, if we needed the answer really fast, we might use one tool. If we needed the best possible, highest quality answer, we would use a different tool. And if we were looking for an optimization routine, we would probably use a different tool. So if you start to think about how does AI help us, it's very, very fast, and it gives us the ability to maybe do an optimization routine much more quickly than we could do it in CFD or the wind tunnel, for example. So AI is maybe the fast tool, and CFD is also an excellent tool, but there are some physical differences in the wheels and the tires as they deform, and the suspension and the body panels all kind of are affected by what we call aeroelastic deformation. And so the aeroelastic deformation is difficult to simulate, and so the wind tunnel allows us to capture those real physical phenomenon in the wind tunnel, whereas the CFD gives us a very, very good look at the pressures and the flow field around the vehicle. So we never want to go into a wind tunnel test, for example, without CFD, because that tells us exactly where the areas of opportunity for improvement are in the wind tunnel. And then AI gives us an even deeper dimension, in that it allows us to do a CFD-like solution in much shorter timeframes.
Interesting. So, which leads me to ask, when you're running a test, our friends in the design and styling department, are they there watching
Yeah, so
anxiously?
our partners from design are generally with us, and we never do anything in 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 exclusion, let's say. And in fact, our job as aerodynamicists is to find the best possible solution, and best possible solution means we want beautiful, efficient vehicles, right? Ugly, efficient vehicles are bad, and beautiful, inefficient vehicles are not so good either. So we're looking for that best possible case scenario where we have beautiful and efficient at the same time. And as an engineer, right, my ability to identify beauty is often questioned. How's that?
Well, the history of the mobility industry is littered with some examples of potentially questionable choices, but I,
Right.
to me, it's all fashion, and that is not my area of expertise, because people have tried to make a truck profile more aerodynamic friendly, and it hasn't always panned out well.
Well,
Um,
at our particular case, we actually enjoy the lowest drag pickup truck in the industry. So we're very proud of having that segment leading product, and our minivan is also the lowest drag minivan in the industry. So it's actually a good business to be in when you have a best in segment kind of vehicle, particularly for something as important as pickup trucks are for us. And certainly our styling is a little bit unique in the industry as well. And so I'm really proud of the work that the aero team at Stellantis has done, and the styling team has done, kind of integrating that pickup truck into a really efficient and beautiful design.
okay. Is this the only wind tunnel in Stellantis?
No, we actually have access to a wind tunnel in Paris, and it's the S2A wind tunnel. We're 1/3 partners with a competitor and also the French government. Then we also own a wind tunnel in Orbisano, Italy, that's part of the Fiat operation, and then of course our wind tunnel in Auburn Hills. So we actually have 3 that we utilize in our business.
Do those 3 tunnels coordinate data?
Yeah,
Is what we test here, does that help our colleagues in Europe?
it does, because we design and develop vehicles in North America that are sold in Europe, and we provide the necessary certification data to do that. And likewise, when they develop vehicles in Europe that are sold in North America, they use their wind tunnel to work with the local engineering and design department. So for example, if you're designing a vehicle in North America, that's where you want the wind tunnel, because that's where the stylists and engineers are. It's inefficient to try and go across regions with that kind of work, and certainly gets into the under one roof scenario we have at Chrysler, or at CTC, I should say.
Okay. So what are some of the challenges, or what I guess a better question is, what are the biggest challenges facing you and your team these days?
So we're always focused on aerodynamic drag, and even more so now that we've moved into the era of electrification. And so the challenge for us is to get the best possible drag that meets the other requirements of the vehicles, because vehicles need to do more than just move through the air efficiently, right? We have regulations for safety, we have regulations for emissions and certification, and so the total vehicle development process is really, really complicated, and so we play a part in that, and so the challenge for us is to work with the program teams and the studios to make sure that we're preserving all those important imperatives along with aerodynamic drag at the same time. So maybe not the exact answer you were looking for, but we're really good at vehicle aerodynamics optimization, and so we work hard to that end. But a lot of what we do in the wind tunnel is, let's say, company confidential, right? How we do it and the areas we focus on and how we tweak things becomes an area of corporate confidential, for lack of a better term.
The work you do here in Auburn Hills, is that always with full-size vehicles, or do you also do scale models to help the process?
We previously have done scale model testing. We recently shifted our focus to just full-scale testing. And so in the past, we've done a considerable amount of reduced scale testing, but just recently we've moved wholly into the full scale realm. But the ability to do more advanced work in AI and the ability to do quicker turnaround in CFD has eliminated much of the need for the reduced scale testing.
Oh, darn. I was going to ask, can I bring my Pinewood Derby car into your tunnel?
Yeah, we could do that, but the reality is we could probably coach you on how to shape your Pinewood Derby car without a wind tunnel test. You want aero engineers that don't need a wind tunnel test to know what the low drag configuration is. So when we're unencumbered by rules and things like that, we can do some pretty cool stuff.
I guess I forgot to ask the most important question. What's the maximum wind speed we can simulate or run through the tunnel?
So we have the ability to go to 140 comfortably. We can push that up a little bit farther towards 160, but at those higher speeds, we've got to really be careful with the acoustic treatments. They tend to want to come off the walls at those higher speeds. So we self-impose a limit of 140 miles an hour unless it's something that absolutely needs to go to the higher speed. So we have the ability to go to 160, but we typically maintain 140.
Greg, this has been a fascinating conversation. I really appreciate you taking the time to talk to us about all things aerodynamics.
Our
And
pleasure.
we didn't even touch on things like wind noise, because I know that that's, from an NVH standpoint, that's a huge issue.
It's a big part of what we do in the wind tunnel, because our aeroacoustic wind tunnel is designed to do both aerodynamics testing and also wind noise testing. And so it's one of the quietest wind tunnels in the world. It was the first wind tunnel designed using computational fluid dynamics. There are some proprietary patents on our wind tunnel circuit design that make it very, very efficient and also very quiet.
All right. Well, on that note, I'll allow you to take a break. And thank you very much for your participation in this podcast.
Our pleasure. Thank you so much.
And thanks to all of you for listening to this Stellantis Tech and AI podcast, where we speak with some of the brightest minds in the tech and automotive industries, like Greg. We invite you to follow Stellantis Tech and AI on LinkedIn and Instagram to join the conversation. Stay updated on what's ahead and be a part of the community that is exploring the fast lane of technology and AI in the automotive world. We'll see you again soon.